Hi dear students. Hi dear students. Today we discuss about the electric field. Before going to the discussion, yesterday we discussed Coulomb force. If you have a source charge Q, then if we keep a test charge capital Q, this is source charge, this is test charge, and we have denoted that separation as R, normal R, and its magnitude is R. Okay. Then the force that we denoted was F is equal to 1 by 4 pi epsilon 0 Q divided by R square, and its direction is around the R. Actually, this representation is not always correct. What I am going to mention here is actually this source charge Q and the test charge Q, if we consider a coordinate system, that is X, Y and Z, then the Q charge, that is the source charge, it is at a distance R prime, and the test charge from the origin, that is at a distance R, that is our usual representation R, vector R. Then the distance from the source charge to the test charge, this distance is, I will denote as this R. Okay. Where this R from the vector laws, traditional law, is very clear that this separation vector R is equal to R minus this R minus this R prime. Its magnitude can be written as R is equal to, that is separation vector R is equal to, we can write R minus R prime. That is, this is the separation vector R. Okay, but we can write in this way if the source charge, that is, this is the source charge, if the source charge is at the origin, ഈ സോഴ്സ് ചാർജ് ഈ ഒറിജിനിലാണെങ്കിൽ നമ്മുടെ കേസ് എങ്ങനെ വരും, നമ്മുടെ ചിത്രം എങ്ങനെ വരും, എക്സ് വൈ, our source charge is at origin here, then our field point or the test charge, that is here Q, then the separation, the distance from the source charge to the test charge, that will be this R. Because if the source charge is at the origin, then here R prime, that is this quantity here is 0. അതുകൊണ്ടാണ് ഈ സോഴ്സ് ചാർജ് ഒറിജിനിലേക്ക് വെച്ചിട്ട് ഒറിജിനിലാണെങ്കിൽ നമുക്കിതിനെ here the force can be written as F is equal to 1 by 4 pi epsilon 0 Q divided by R square, R cap. but in this case, the force between the two charge, that can be written as F expression vector R is equal to 1 by 4 pi epsilon 0 q divided by R square. Then this is separation vector R cap. Okay. This is the exact form of the Coulomb force, and this case is one special case of this problem. Special case means where the R prime is 0, that is the source charge is at the origin, therefore R prime is 0. Therefore in that case, that is as a special case, we can write F is equal to 1 by 4 pi epsilon 0 q divided by R square. നമ്മൾ സാധാരണ നോർമലി ഇങ്ങനെയാണ് എഴുതാറുള്ളത്. ഇങ്ങനെ എഴുതുന്നത് തെറ്റല്ല. ഇവിടുത്തെ മീനിങ് നമ്മൾ മനസ്സിലാക്കേണ്ടത്, നമ്മുടെ ഈ സോഴ്സ് ചാർജ് വെച്ചിരിക്കുന്നത് കോർഡിനേറ്റ് സിസ്റ്റത്തിൻ്റെ ഒറിജിനിലാണ് എന്ന് നമ്മൾ മനസ്സിലാക്കണം. അങ്ങനെയാണെങ്കിൽ നമുക്ക് ഇങ്ങനെ എഴുതുന്നതിൽ കുഴപ്പമില്ല. If the source charge is not at the origin, if it is at a r prime distance away, then from that source charge to the test charge, the distance will be r. This r is a separation vector r. Okay, ഇത് നമ്മൾ ശ്രദ്ധിക്കേണ്ട ഒരു പോയിന്റാണ്. Now let us come to the discussion of electric field. നിങ്ങൾ പ്ലസ് ടു ക്ലാസ്സിലൊക്കെ ഇലക്ട്രിക് ഫീൽഡിനെ കുറിച്ച്, ഇലക്ട്രിക് ഫീൽഡിൻ്റെ ചാർജിനെ കുറിച്ചൊക്കെ കുറേ പഠിച്ചിട്ടുണ്ടാവും. ഇവിടെയും അതിൽ നിന്ന് അഡീഷണൽ ആയിട്ട് ചില കാര്യങ്ങൾ കൂടെ നമ്മളിവിടെ മനസ്സിലാക്കുന്നുണ്ട്. Okay, see this picture. Here we have the XY Z coordinate system. We have a large number of charges. That is, these are the source charges. That is Q1, Q1, Q2, Q3, etc. Qi. And from the origin to the source point, this is the source point where the source charges are situated, and from the origin to that source point, the distance is r prime. It is ri prime. Ri prime. And from the source point to the field point, that is P is the point where we are interested to find out the electric field due to these source charges. That is why this point P is called a field point. And from the source charge to the field point, the separation vector is Ri. That is, this is actually Ri. That is, the bolded letters in the Greek textbook is nothing but vector quantities. From the origin to the field point, that is this distance, that is denoted by usual vector r. Here I want to calculate the force on this test charge Q. If I place at the field point P, that is, the total force on the test charge Q will be the force due to the charge 1, that is force exerted by the Q1 on this Q, capital Q, and the force exerted by the source charge Q2 on the test charge capital Q. That is, we have to find the force by each charge separately. Okay, there is a total force on F, that is F is the total force on the test charge Q, means we have to first calculate the F1. F1 means the force exerted by the first source charge on the test charge Q, that is vector sum. Force exerted by the second source charge on the test charge Q is F2, and so on. Okay. This can be written as the Coulomb force we have already know, 1 by 4 pi epsilon 0 is Q1 Q divided by the separation vector square, that is R1 square into R1 cap plus Q2 into Q divided by separation vector R2 square, R2 cap, so on. That is, here the Q I can take it outside, as Q by 4 pi epsilon 0, take it outside, then the term in the bracket Q1 separation vector R1 prime divided by R1 plus Q2 by R2, R2 prime, etc. Then I can write this expression, that is 1 by 4 pi epsilon 0 into Q1 R1, Q1 by R1, actually here we should have square, and Q1 by R2 square, this term. All this quantity I can represent like this, R. Then in this equation F can be written as F is equal to Q into E R. Fine. Or simply I can write this as a E, QE. F is equal to QE, where the vector ER, that is equal to 1 by 4 pi epsilon 0. I can write this as a summation, that is summation over I is equal to 1 to, if there are n charges n, then this will be Qi divided by Ri square, then Ri cap. That is, this E is called the electric field of source charges. That is, we are interested at the point P, then at the point P, the charges, that is these source charges Q1, Q2, Q3, etc., that produces a field at the point P, that is at a distance separation vector R from the source charge. That field created by these source charges are given by this expression. Then if this is an electric field due to a large number of source charges, then what will be the expression for a single charge? That is electric field due to a single charge, that can be written as E equal to 1 by 4 pi epsilon 0, here no need of summation, Q divided by R square R cap. Here R is a separation vector R. Here it should be noted that this electric field is a function of R, not a separation vector R. This is a function of R. Why? Because the separation vectors, that is Ri, depend on the location of the field point P. Okay. That is, if you see this figure, this R depends on the field point P. That is why the electric field E has been written as is a function of R. This is nothing but vector R. Now let us examine this equation, that is F is equal to Q into E. Then what is the definition of the electric field? From this expression I can write electric field as E is equal to F by Q. One can define the electric field in this way. Field, you see, electric field is nothing but a force. Okay, that is, electric field is a region around an electric charge. Suppose here we have a source charge Q. The region around this electric charge, if I place another charge, that is test charge, then if the test charge experiences a force, that force may be either repulsive force or maybe attractive force, then this electric field can be defined as in this way. This is a region around an electric charge where other charge experience a force. That is, can be defined as a region around an electric charge in which other charge experience a force. Now, what will be the intensity of the electric field? What is the strength of the electric field? That is, the strength of the electric field is denoted by intensity of electric field. That is a intensity of the electric field at a point. How we can define that one? If you see here, we have electric field E is equal to F by Q. If there is in some region there exists an electric field E, I want to calculate the strength of the electric field, intensity of the electric field at a particular point. For this, I place a 1 Coulomb charge. That is, here I placed this 1 Coulomb charge. Then I measure what is the force experienced by this charge. Then that force will give the strength of the electric field at this particular point. That is, here electric field intensity can be defined. This electric field intensity of the electric field at a point is defined as the force experienced by a unit positive charge placed at that point. That is, if Q is equal to 1 Coulomb, then this expression gives E is nothing but F. That is the electric field at a point is defined as the force experienced by a unit positive charge placed at that point. Okay. Now let us do a problem to calculate the electric field due to some charge configuration. This is an unsolved question in the Griffith textbook. The question is one: find the electric field, that is where you calculate both the magnitude and direction of the electric field at a distance z above the midpoint between the two equal charges Q at distance d apart. That is figure 2.4. This is a figure 2.4. The two charges is kept at distance d apart. Then we had to find out the magnetic field. We had to find out the electric field at the point P. That is, this point P is at a distance z from the center of the two charges. Okay, to solve this problem, first let us find the electric field due to this charge. Let us write this charge is situated at the point A, and the second charge is situated at the point B. Then electric field at the point P due to this Q charge, that I can write in this way. This is the electric field due to the charge placed at the point A. The charge placed at the point B, that produces an electric field that is away, because the electric field due to plus Q charge is always away from the charge. That is why we have given the direction outward. And with respect to the Z, this electric field make an angle theta. Here also to make an angle theta. Then if you resolve the electric field component into two, is along the adjacent side, this will be E cos theta, this will be EA cos theta, and this electric field that you can denote by EB. If I resolve this one, that you know very well how to resolve these vectors. The adjacent side will be EB cos theta. Then the perpendicular components will be along this one for this vector. This will be EA sin theta, because if you resolve, because this is angle theta. EB, this will be EB sin theta. It is clear that these two, EA sin theta and EB sin. Then what is this EA and EB? EA is the electric field at the point P with the charge placed at the point A. That is 1 by 4 pi epsilon 0. I take this distance as r. This is also r. Then it will be q by r square. I am writing the magnitude only. What about EB? EB is a electric field at the point P due to the charge placed at the point B. That electric field is 1 by 4 pi epsilon 0. Once again, q divided by r square, because both have the same length. Therefore, it is clear that EI is equal to EB is equal to E. Okay, that is equal to 1 by 4 pi epsilon 0 q divided by r square. Now, if you we can write this is nothing but E A sin theta can be written as E sin theta, EB sin theta can be written as E sin theta. Then this will be E cos theta, E cos theta. Then here we have these two, E cos theta will be added. That is the net electric field at the point P, that is equal to the 2E cos theta. Net electric field at the point P means 2E cos theta, because these two components will cancel each other. Only the cos theta component survives. That will be added, and this E is given by this expression 2 into 1 by 4 pi epsilon 0 q divided by r square. From the figure cos theta, if this is a theta, this angle will also be theta. If you work out, you can easily find out this angle also be theta. cos theta is equal to adjacent side. Adjacent side means here it is given. This is nothing but the z. So z is here. That is not clear in the picture. I have written this is z. Adjacent side means z divided by hypotenuse. That is r. Then I can write it instead of cos theta, z by r. It is 2q divided by 4 pi epsilon 0 r cube into z. Then next what we have to do? We have to replace this r. From figure it is clear that r is equal to, r is hypotenuse, that is r square is equal to this 4 square d by 2 whole square plus this z square. That is r is equal to root of z square plus d square by 4. Then next, here we want to find out r cube. That is r cube is equal to root of z square plus d square by 4 whole power 3 by 2. Then the electric field can be written as E is equal to 2qz divided by 4 pi epsilon 0 z square plus d square by 4 whole power 3 by 2. This is an expression for the magnitude of the electric field. Then the direction, what will be? It is clear in the picture that if we have this electric field component alone, this direction is nothing but our z direction. Therefore, the electric field is alone the z cap. Therefore, this is alone z cap. This is the electric field expression for the electric field intensity. Now, what else in the question asked? That is for z greater than d, very much greater than d, which means in this picture, it is this is z axis, that is very much greater than d. D is the separation between the two charges. This is d. If z is very much greater than d, d is very small, therefore d square be very small, that can be neglected. Therefore, here this d square can be neglected. Therefore, electric field will be 2qz divided by 4 pi epsilon 0 z square plus 0 power 3 by 2, and this electric field can be written as 1 by 4 pi epsilon 0 2qz divided by 4 z power cube, that is electric field can be written as 1 by 4 pi epsilon 0. Here z prime z cap is the is z and z cube cancelled. Therefore, this will be 2q divided by z square z cap. This is the final expression of the electric field if z is very much greater than d. Okay, now the second question, B question. Repeat part A, only this time make the right-handed charges minus q instead of plus q. That is, now you have to do this question as a homework. And what is asked is, this in the given question, only thing that you have to replace the right-handed charge, this the right charges instead of plus q. you have to take this as a minus. Then take this as a minus q, this as a plus q. Find the net electric field at the point P. That is the homework. Okay, thank you very much for watching this video.